All right, everybody, we are moving on to chapter 9 now. Chapter 9 is a lot different than the last chapter and pretty much everything we've been doing at this point. Hypothesis testing is going to take a little bit of a break for the next 2 weeks, but we'll come back in 9.3. I think this is going to be a lot easier for most of you. And as far as the work goes, it's really just using the computer to calculate everything for you, um, at least in terms of the math. We will be looking at a different type of graph that we kind of made this year, but it's been a very long time. So this chapter is all about the relationship between two quantitative variables. So in the last chapter, chapter 10, we looked at the relationship between two qualitative variables. So if you go to all of the examples that we did in 10.2, they were all about two qualitative, for example, well, or one qualitative. But we had examples such as, I'm trying to think back to the examples we did. Oh, we had the travel concern and the travel purpose. Those are not quantitative variables, not measuring anything, they're qualitative. But now we are shifting to two quantitative variables, such as, say, height and weight. Those are two variables that are measuring something. We're looking at relationships between those. So this section really only has two ideas in it. It's, like I said, not going to be a hard section really for anybody. And that is, first of all, how do we graph this? How do we graph two quantitative variables? And lastly, how do we measure the relationship? So before we talk about the measuring relationship, we're going to look at first how to graph them. So in order to do that, we're going to look at our first example here. It says an economist wants to determine whether there is a linear relationship between a country's gross domestic product (GDP) and the carbon dioxide (CO2) emissions. The data are shown in the table below. Display the data in the scatter plot and describe the time correlation. So we have two things going on. We're just going to look at how do we actually display this data in a graph. So you'll notice right here we have a table with numbers. And we have the GDP and the CO2 emissions. Both of these are quantitative. They're not qualitative variables. GDP is measuring the amount of money, and the CO2 emissions obviously is measuring how much CO2 there is. So to do this, we need to make what's called a scatter plot. And it's telling us to do that right here, make a scatter plot. Most of you probably made a scatter plot before. It's not anything that's overly difficult to do, but it's just something you have to do. So scatter plot, always, okay, if you have a table that looks like this, where you have them kind of vertically, the one on the left is always going to be your X variable, and the one on the right is always going to be your Y variable. Okay, I'm not going to trick you with that. That's the way it's always going to be. If you have a table with like numbers like this, just making stuff up, doesn't matter. A horizontal table, the top variable is always going to be X, and the bottom variable is always going to be your Y. That will never change. Nothing you need to worry about there. It's always going to be that way. No tricks. So we know which is X and which is Y now. So I'm going to go ahead and start making my graph here. So scatter plots, obviously in most graphs, you're going to put your X on the bottom and your Y over here. So now I need to come up with the scale for this. So looking at my X's right here, I'm starting at, looks like my smallest is 0.8 and my biggest is 5.9. So we could either go by 0.5s or we could go by 1s. I guess I'll go by 0.5s just to have a little bit more accuracy, but if you want by 1s, I don't think that'd be that big of a deal. No, maybe I'll just go by 1s and leave some space. All right, so I'll go by 1s. So 1, 2, 3, 4, and you go to 6. And then for Y's, I'm starting at 253 and going to 1,180. So maybe go by 100s. I'm not going to write every number here just because it's really hard for me to. Well, it's a little bit of a problem, but it's all right. So next thing I'm going to do before I forget is I'm going to label my axes. So we have GDP as my X. So we'll write that. I'm going to write in trillions of dollars. And then my Y is CO2 emissions. And I should be writing the units, but I have no room and it's hard to write this, so I'm just going to write CO2 emissions. And I'm probably going to erase this because I can't see the numbers now, but you should write CO2 emissions. Okay, so CO2 emissions, we've labeled both of our axes, so we're good there. Now we just need to plot the coordinate points. So my first set we have is 1.7552. So I'm going to go to 1.7, which is not quite halfway between 1 and 2, but a little more to the right, and go up to 552. So it's going to be about right here-ish. You know, maybe a little higher up. We don't need to be perfect here, but yeah, more like that probably. So notice how I was, nope, that's too far to the right. Let's try one more. So we'll do this. We're not changing it. So you'll notice that up here, it's about where 1.7 is, and about halfway at 550. And that's how I can make the point. So I'm going to continue to do this for all of them. I can graph all these dots. So I'm at 1.24 something, 460. I'll do the best I can with this. 2.5, 475. 2.8, 375. We're at 3.6, 784. Right there. 2.2, 400. There. 0.8, 253. 1.5, 318. 2.4, 496. And lastly, 5.9. And it's on the way up here. And that is about what our graph looks like. It's not perfect by any means. So it's probably a little off, but it's a general idea here. So this is a scatter plot. When we have two quantitative variables, this is the type of graph we have to make, and you'll be making a few of these this week. Just to get the hang of it. Make sure, once again, that your axes are labeled. Okay, make sure you label both of those axes with whatever the variables are on the table. And then just make coordinate pairs. Probably the hardest part is just coming up with the scale. You have a hard time figuring out what to go by, but hopefully most of you can get that down. So there you go. We made a scatter plot. That's half of what we're doing this week. Okay. Once again, not hard. Most of you have probably made these before, so I'm not really worried about that at all. Now, the other thing we want to do is we want to talk about the correlation. Okay. So let's go ahead and define correlation here. Okay. A lot of people use the word correlation. You know, I'm just going to type it. And in statistics, it has something very, very specific what it means. We can't just change the meaning like we're used to in everyday language. Correlation in everyday language just means there's some sort of relationship. Okay, this is related to this somehow. But in statistics, it means something very particular, not just any relationship, but a special type of relationship. So the definition of correlation is the strength of the linear relationship between two quantitative variables. So you'll notice that one is talking about strength. So we have the strength. So how strong is it? Correlation refers only to linear relationship, and they have to be quantitative. So we can't use correlation for any of the stuff we did last week because those weren't quantitative, they were qualitative. The word correlation wouldn't make any sense. We'd have to use the word association. And strength, how strong of a relationship is that? And when we use correlation, it's talking about linear relationship. So correlation, we're going to find out here shortly, is a number. You can actually calculate a number that shows how strong the linear relationship is. The symbol for correlation is a lowercase r. It just is. So it's an r. It doesn't, I don't know if it looks like an r or not, but it is a lowercase r. And correlation has to be between the values of -1 and 1. Anything outside of that is something went wrong. Correlation cannot be less than -1, and it cannot be bigger than +1. So there's no set rule about how strong something actually is. Like I'm going to give you a sort of idea of how you can do this, but this doesn't end all be all. So usually what happens is the closer to 1 or -1 the value is, the stronger the relationship is, and the closer to 0 it is, it means the weaker the relationship is. Where 1 and -1 have a perfect correlation, it would make a perfect line, and 0 means it's just a blob. There's literally no relationship there at all. With at least it's linear. So usually, let's go from, I don't know, -0.3 to 0.3. So anything in this range we'll say is weak. So any correlation that you have between -0.3 and 3, so 0.15, we'd say it's a very weak relationship. Once again, this isn't the end all be all. So then let's say anything from 0.3 to 0.8. So let's say in this area here, in this area here, it would say it's moderate. So there's a moderate linear relationship. And then we'll say anything from 0.8 to 1. Anything from -0.8 to -1, we'll say is a strong linear relationship. So that's how we deal with strength. You know, obviously, if it's negative, that means there's a negative linear relationship. So you'd have something that has like a negative slope like that. And if you have a positive correlation, then anything that's positive, you'd have a positive slope with a linear relationship with the line that it's kind of making. So another thing we can do is we can make some pictures of what these scatter plots would look like. So if I have something that looks like this, okay, I can kind of see a downward trend here, but it's not a very precise relationship. So this we would describe as maybe a weak negative relationship. So there's a weak negative linear relationship. If we had something like this, we can kind of see that upward trend going right here. So maybe this would be moderate. And the direction of this is positive. Because as x increases, y also increases. This one as x goes up, y goes down. And then we can do a really strong one here. Really quick, find something that's really precise. You'll notice that this is making a very good looking line. Okay, there's not a lot of variation from those dots. This would be a strong positive linear relationship. So these are how we can look at the number for the correlation, and then in practice, what the actual scatter plot's going to look like. Okay, so we go back to our data here, we can see that there is sort of this positive trend here. Okay, how strong it is, hard to say just by looking at it. But it's pretty strong because you can see the line, maybe moderate. So maybe we'd say there's a moderate, definitely positive linear relationship. But rather than having to just estimate it, we can actually calculate that R. So that way, when we have the number, we can look at something like this and then figure out, is it strong, moderate, or weak? Now, I'm not going to go over how to actually calculate correlation. It is a very yucky calculation. It is not easy to do. Well, it's easy to do. It's just really, really, really tedious. You have to, it's just, I'm not even going to go over, I'm not even going to write the formula down. It is just a beast to do. So just like our last few weeks, I'm going to give you a place online that you can do this in. If you want to use your calculator, feel free to Google how to do it. It's not hard. It's using lists. You type your X in list 1, Y in list 2, stat over to calc, lin reg. It's not that hard to do. But once again, the majority don't have calculators, so I'm going to be showing you that method here. So I will post a link to this website. The reason I'm picking this website, I don't know if it's the best, but what it will do is you'll notice here, I'm clicking different dots. It's also going to find a regression line, which we're going to do next section. So what's nice about this site is you can type in the values once, and then you can just change what you want it to calculate. So you don't have to type it in twice. It was one of the first sites I found that did both of these for us. But it's going to ask you for your X and Y values. So what you would do then is you just type in whatever your first X value is, hit space. Your second one, hit space. Your next one, hit space, so on and so forth. And then do the same thing with the Y. So type in your first Y, your second Y, your third Y, so on and so forth. You just type them in with a space between. And then you just go down to compute. Make sure you pick correlation coefficient. That's all we're doing right now. And you don't really need to do a show me an explanation because we just want the answer. Now, I went ahead and before I typed these values in, so you'll notice that it'll do decimals just fine, but you'll also see there's a space between each of these numbers. There are more numbers below it here. Just keep doing those spaces and it will space everything out for you. So type the number, hit space, type the number, hit space, you'll be good. I want to find a correlation coefficient, so I have that selected. I don't need an explanation, and you hit compute. Scroll down. It'll show all your data, a nice little table for you right there, and then bingo. You'll see, you probably can't see what I'm doing here, but you'll see R equals 0.9112, and there's your correlation. So this is all you have to do to get your correlation. Just type the numbers in for X and Y. Remember, X is either on the left or the top. Excuse me, of a table. Y is either on the right or the bottom. And that, you hit compute and you're done. So R equals 0.9112. That is our correlation. So the correlation is equal to 0.9112. Now we can go back to our little chart. And remember, the green is our strong, so 0.91 is definitely between 0.8 and 0.1. So it is a strong relationship here. It is linear, and it is positive. So when we interpret the correlation, which you will have to do, we would type there is a strong because 0.9112 is pretty close to 1. Positive because 0.9112 is positive. We also saw that positive trend. Linear relationship between GDP and CO2 emissions. And we just interpreted the correlation. That's it. So these are the two skills we're going to be working on this week. Okay, you need to be able to make scatter plots. Okay, in your assignment, you're going to be making a few scatter plots. And then I'm going to have you calculate the correlation and have you interpret that. So strong positive linear relationship between GDP and CO2 emissions. I'm going to do one more example. If you think you got it down, awesome. But I will do one more example here. Okay, so it says the student conducts a study to determine whether there is a linear relationship between the number of hours a student exercises each week and the student's grade point average, GPA. The data are shown in the table below. Display the data in scatter plot and describe the type of correlation. We're going to do more in describer and actually calculate. So same thing here. We make a scatter plot of the data. So X is always on the top. So my X is going to be hours of exercise. The GPA is your Y. So then when I make my axes, GPAs or hours of exercise is down here. And then GPA is over here. So looking at hours of exercise, we start at 0, go to 18, so maybe 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And then GPA, maybe 0.5, so you have to go up to 4. So 0.5, this is 1, 1.52, 2.53, 3.5, and then 4. Plot these really quick. 12, 3.6 is right about here. 3, 4.0, right about here. 0, 2.5 is right here. See, it's on the axes. Sorry, 0.3.9, my fault. Okay, so 0.3.9. We'll use different colors. We'll go here. 6, 2.5. Here. 10, 2.4. Over here. 2, 2.2. Over here. 18, 3.7. So maybe here. 14, 3.0. So here. 15, 1.8. Here. And 5, 3.1. So this doesn't look like anything. Hey, I don't see any slope. There's no positive line going like this. Maybe slightly negative. I honestly have no idea. This looks like a blob. Okay, when you have a blob, like if I do the line of best fit, it looks like it's just going straight through there. When you have something like that, we're going to get a really correlation that's going to be very close to 0 is my guess. So just by judging this, I would say there's a weak to no correlation or linear relationship here. But we can calculate the correlation. There doesn't seem to be a linear relationship here to me at all. Let's go ahead and calculate it. So once again, I went ahead and typed in all the numbers. And I can go back, I suppose. Typed in all the numbers. So you type in all of your numbers into the table. Go ahead and click on the find the correlation, hit compute. It'll put you in the table here. Makes it look all pretty, at least on my screen. It's not doing it right now, but the correlation I can see is negative 0.1639. So apparently it's slightly negative. Once again, there's really nothing going on there. But I see R equals negative 0.1639. So R equals negative 0.1639, I think I said. Let's just double check. Yep. So we're describing our correlation for this. Okay. I would say there is a very weak negative linear relationship between GPA and hours of exercise, which I suppose makes sense. I don't know how much exercise you can do to GPA. So yeah, there's like nothing going on here, but that's how we would describe it. So there's a very weak. So we always say the strength part first, usually, because it sounds the best way you write it, or how it sounds when you write it. So the strength, then the direction. So we had negative because it said negative 0.16 something. And then it's always linear relationship because that's what correlation is measuring. So there's really no linear relationship here. Okay, I would just say, hey, I don't see anything going on here. There doesn't seem to be any relationship at all between hours of exercise and GPA. We can go ahead and just use that same interpretation that we use for correlation. So very weak negative linear relationship between GPA and hours of exercise. All right, that's everything there is in 9.1 for right now. Like I said, this should be a pretty easy section. I'm not going to be giving you quizzes for this. In the next section, I will give a quizzes over both sections together, which means that you only have 2 assignments again. So you'll have your notes, and then I'll post a written out assignment to have you practice calculating correlation with the computer and making scatter plots and making sure you're doing that right. All right, hope everyone's doing well. Hope this video is helpful for you, and I will talk to you guys later.